Today we're going to talk about simplifying radicals. And so when you're simplifying radicals, there are three things that you have to remember. The first is there should be no perfect square factors other than one that are in your radicand. Remember that the radicand is just the number that's underneath the radical sign. And so when we're talking about square roots, which we mostly will today, it's the number that's underneath the square root symbol. There should be no fractions in the radicand, and so you should never have the square root of something like 3/4. You should always change that. At first that'll seem easy, but then understand that there should be no radicals that appear in the denominator of a fraction either. Understand that you can have fractions, but you cannot have a radical that is in the denominator of a fraction. And we'll work with each of these three rules, but these are the three main rules of simplifying radicals. Along with this, understand if you ever have a fraction, meaning that the numbers are outside the radical sign, you will want to reduce those down. And again, we'll look at examples of all of these, but those are the three things to keep in mind. Really, when we work here, we'll work with these two main properties here. And as you look at the product property of radicals, states that if you have the square root of AB, the square root of AB is equal to whatever the square root of A times the square root of B is. And so to do one that we know what the square root of 36 should turn out to be. So let's look at this as a proof. The square root of 36 should be the same as the square root of 9 times 4, because 9 times 4 is 36. What the product property is saying is that the square root of 9 times the square root of 4, if I separate those, should also equal 6. Well, the square root of 9 is 3, the square root of 4 is 2, 3 times 2 is 6. And so you can see that the product property of radicals is going to work. The quotient property is real similar. The quotient property says if I have a fraction, a over b, and I'm taking the square root of that fraction, a over b, that is the same as taking the square root of a over the square root of b. And so I can take the square root of both of those. And again, I could do an example like this and show that that's going to work each time. And so those are the main properties that we are going to use there. So let's look at just a quick example here. As we look at a quick example, let's look at 28. Now, if we think back, the first rule had to deal with perfect squares. The other two had to deal with fractions. I'm okay with fractions. This is in the numerator. There's no fraction or anything like that. I'm okay there. But the perfect square one is what I'm looking at. Remember your perfect squares. The numbers you're looking for are numbers like 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. These are the numbers that you're looking for to go into it. And so I'm looking at 28 and I'm thinking, what if any of these numbers go into 28? And I see one right away, 4 goes into 28. And so what I'm thinking of is that the square root of 28 is the same as 4 times 7. Oops, that's a times. And so that's the same as the square root of 4 times the square root of 7. Well, the square root of 4, I can do that. The square root of 4 is 2. And so the simplified form of the square root of 28 is 2 square root of 7. Notice that this answer is exact. And so we always want exact answers. We don't want to put it on the calculator and get a decimal. But it is simplified from being the square root of 28 to being the 2 square root of 7 there. Think about square root of 75. And feel free to hit pause and kind of try to do this on your own if you want to check it there. Square root of 75 again. We have to check, are there any perfect squares that go into 75? And as you look over here, 4 does not go into 75. 9 does not go into 75. 16 does not go into 75. But 25 does. Since 25 goes into 75, I again look, it goes in there 3 times. So 25 times 3 equals 75. That is the same as the square root of 25 times the square root of 3. Apparently I had bacon on my mind. I made a little thing of bacon right here. Just hot, sizzling bacon right above my radical there. Square root of 25 times square root of 3 is 5 square root of 3. And so I've simplified that down. Let's look at the ones that get a little more difficult. It's when we have fractions. At first glance, it seems simple. I can't have a fraction, but my quotient property says that that's the same as the square root of 48 over the square root of 49. But remember that third one that we had there? We cannot have a radical in the denominator. So I do need to go through and do the square root of 49. That is 7. And I also have to figure out what perfect squares go into 48. Well, I know 16 does, so I have the square root of 16 times 3. The square root of 48 can be broken into the square root of 16 times 3. As we go and look at that, that can be broken into the square root of 16 times the square root of 3. Square root of 16 is 4, so we have 4 square root of 3 over 7. Now we look at it, 4/7 cannot be reduced. They're both outside the radical. So if they could be reduced, if it was something like 4/8, I'd reduce that down to 1/2. I can't reduce anything with the 3 here because the 3 is inside the radical and nothing else is. And so that ends up being my answer there. This example that we're going to do is going to be over what appears to be a simple problem at first. It's going to be just the square root of 4/7. Can't have a fraction, so we know we got to bring that square right into both the numerator and the denominator. Now, the square root of 4 is easy. The square root of 4 is 2. But remember, we cannot have a radical in the denominator there. We cannot have the square root of 7 in the denominator. So I got to get rid of that somehow. Before, it just worked out nicely for us. It was one of our perfect squares. But now it's not. And so we got to be able to get rid of it. We're going to do a technique that we've done quite a bit. We're going to actually multiply the square root of 7 times the square root of 7. Now, if I just multiply by square root of 7 on the bottom, I'm changing it. But the technique that we've done frequently is you multiply by the square root of 7 over the square root of 7. Realize what you're actually multiplying by here is 1. You're taking 2 over the square root of 7 times 1, because the square root of 7 over square root of 7 is 1. And so I can multiply across. Now the square root of 7 times square root of 7 is the square root of 49. The square root of 49 is just 7. That is not a coincidence. That will happen every time as you go through problems. And so for instance, you can take something crazy like the square root of 157, and if you multiply that by the square root of 157, I don't know what 157 times 157 is, but I do know that when I take that, I'm taking 157 times 157, that's going to be 157 squared, and if I take the square root of 157 squared, I get 157. And so that pattern happens every single time. Check to make sure you're done. Can I reduce 2/7? No. Is there a radical in the denominator? No. Is there a perfect square that goes into the square root of 7? No. So I'm done. Okay, and so please do remember here, when simplifying radicals, there can be no perfect square factors other than one that are in the radicand, which is the number under the radical. There can be no fractions that are in the radicand, so you can't have, for instance, the square root of 3/4. And there are no radicals that appear in the denominator of a fraction. So if you do have the square root of 3/4 and you change it to the square root of 3 over the square root of 4, you do have to get rid of that radical in the denominator, so you'd have the square root of 3 over 2. And as always, I do like to end with a few jokes. And so as you look at the first thing there, that is my poor drawing of a peanut. And so what did the nut say when it sneezed? Cashew. Why didn't the teddy bear eat his dessert? Because he was stuffed. And finally, if hot and cold were in a race, which is faster, hot or cold? Hot, because you can catch a cold. Have a lovely day. We'll see you tomorrow.